All right, let's look at circular motion part 1 problem types. So our first one is just circular motion. So I have something rotating or going in a circle. If that is true, you're just going to list out your variables and choose an equation. Direction here, we're going to use clockwise as the negative direction, counterclockwise as the positive direction, or you can use that right-hand rule. So remember, you're going to go ahead and put your palm on the axis of rotation, curl those fingers in the direction it's rotating. Your thumb will point in the direction of the velocity or acceleration or displacement. Out of the page is positive, into the page is negative. Our second type is when we have a constant angular velocity, meaning we have a constant omega. You'll see the words uniform circular motion, or the angular acceleration is 0. If this is the case, omega naught and omega are the same thing. Alpha is 0, so you're going to be using equation 2. We also use some new terms here. We can talk about the frequency, or we can talk about the period for that uniform circular motion. So frequency is 1 over the period, the time it takes to go around 1 time is the period. And we can relate this to the angular velocity, in that the angular velocity is 2 pi radians divided by the time it takes to go around once the period, or we can do 2 pi times the frequency. We also have linear and rotational quantities that we need to relate. So if you do have a combination of linear and rotational quantities, it is a linear and rotational problem type. So you have to relate the linear distance to the angular displacement, the linear speed or the tangential speed to the angular velocity. And then we have tangential acceleration or linear acceleration, which goes with alpha. And we have the radial acceleration, just another component of our linear acceleration, which is v squared over r, or omega squared times r. Lastly, if you have forces in a circular motion problem, we have a sum of the forces in the radial direction equals ma rad. We kind of have a second law problem here talking about the change in direction of that circular motion. So what you need to do there is you need to draw a free body diagram, identify the circular motion. So sometimes it might only be a part, like going through a valley on a roller coaster. It's only part of a circle. So you need to identify that circular motion, draw a rad, always radially inward, and make that your positive direction, sum up the forces in the radial direction, set it equal to ma rad. And as always, if you want to see a video about these problem types, go ahead and go down to the description, and there are links there.